And our next simplification is going to be about the assumption of ergodicity. And it's a big word, but I will spend a while trying to explain the major point about it. So we can basically think of two kinds of analytical approaches if we're collecting empirical data. So we could have um, either a lot of individuals and many variables, or we could have just one or a few uh, individuals with many variables, but with many time points. So here we only collect one time point out of every individual and every variable, whereas here we collect um, many time points of a single individual. And in an ergodic system, these two are give you the same result. Basically. So in a way, here you have a um, matrix where you have days as columns and people as rows. So you have the blue box. So for each day you have measured for person one, you have measured the variable x and variable y, and you get this intra-individual correlation, like one number. How much do these two variables correlate with each other? Whereas on the so this is the time average or the time correlation. And then on the in the red box, you see the uh, uh, ensemble correlation. So you see for this one day, for each person, what is so their values for this pair of variables, and you get this cross-sectional correlation from that on the bottom. And if the system is ergodic, you should have these two should produce the same result, and which would kind of mean that you can treat your uh, sample as interchangeable. And this is very important for many, implicitly often in many survey methodologies and the analysis of survey data. And I warmly recommend you to listen or read the book by Todd Rose on the end of average, and he talks about this issue also. And so basically, in an ergodic system, this time average and the ensemble average are equal to each other. So to give an example, in an ergodic society, if you would have a 100 possible professions, each person would spend 100th of their life. So if they would live 100 years, they would every year be in one of those 100 professions or something like this. And you could, if you were to measure a single person 100 times, it would give you the same result as measuring 100 people just once. And when you have a system like this, you can generalize from group level data to individuals. So you can look at, oh, hey, so these emotions and social influences, they have this sort of relationship on the population level. So I can assume that for any given person, the same relationship holds. But if you don't have a system like this, then this is essentially doing something called the ecological balance. And there's a funny or a nice example in this very funny book called Alchemy by this sort of uh, very well-versed marketing executive who also knows their way around the uh, behavior change world. But in a way, you can imagine playing a game where four people play this game where they throw a coin and they start with 100 euro bet. And if they get head, they win 50%, so they get like 150. And if they get tails, they lose 40% of whatever they had at the moment. So let's imagine. So four people throw the coin. The first two get heads, and the second two get tails. So they lose 40%, and the others win 50%. And now in round two, uh, the first person flips head and wins again 50% of their current stake. And then the second person flips tails and they lose 40%. And third person flips head, they win 50% of what they had. And the fourth person flips tail again, and they again lose 40% of what they had. Now look at this situation. Uh, Basically, what you see here is that the total wealth has gone up. So from 400 euros to 441 euros. But on the other hand, most people are worse off than when they started. And this is quite interesting because it's been claimed that both traditional and behavioral economics fail due to ergodicity uh, uh, issues and because they fail to take into account the repetition of this, what people do in normal life. And if you want to read more of this, there is a person called Ola Peters, so O-L-E Peters, who has written the first textbook about this stuff. And it's quite approachable if you look up his YouTube videos. And one final example, think about if would you play 100 one times Russian roulette if someone gave you 100 million? And if you said yes, well, would you play Russian roulette 10 times if you were promised 10 billion for it? And this is sort of simple scaling up, and in an ergodic system, it shouldn't make a difference. Whereas, of course, in real life, it does, because we have these, what Nassim Taleb calls absorbing barriers. So we hit ruin and we may never return, which is why, for example, loss aversion, which is this sort of it's been considered a bias that hampers our decision making, because we overemphasize the same percentage loss to the same percentage compared to the same percentage gain. And but this is completely rational if you think of it in a way that we really need to avoid destruction in order to do any sort of flourishing in the world. And just to leave you thinking with this, which one is more important, the number of times you're wrong or the consequences for being wrong? And you can consider the Russian roulette example with this in mind. And also, curiously, when we're doing analysis, oops, the main goal of hypothesis testing is to control the long-term error rates. So how many times you make a claim that there is something when there is actually nothing to see. The type 1 errors and type 2 errors, like you fail to notice something even though it's there. And you in normal hypothesis testing, which is usually thought completely wrong in the social sciences, you need to balance these two error rates, but still you're within the box of thinking that the number of times you're wrong is the most important thing, which it obviously isn't if you're in a situation that actually matters. And I'll give you one more practical example of my own data when I started looking at, okay, so because ergodicity, it requires homogeneity of individuals, and also that they follow the same dynamical laws, and the stationarity of and their time series data. So we asked a bunch of people we beeped them on their mobile phone and gave them a survey many times a day, and they had to respond to questions regarding their work motivation. And these are 6 categories of work motivation. It doesn't matter what they mean for now, but so in the beginning of study, or the observation period, which took, I think, 2 months or something. In the beginning of the period, this is what the relationship looked like. So if someone felt this, that what they were doing is but they're doing what they're doing because it's very important. The next time point, so this is the importance node. So the next time point, they felt less that they are doing something because they want to avoid guilt or anxiety. And in the same manner, you have the yellow one on top, the pleasure one. So if a person reported doing what they did because it's pleasant, the next time point they were actually more likely to report that they are doing it out of wanting to avoid guilt or anxiety. You could think of stories for this. So they're doing something fun, and then they need to, and the next time that they do something, they need to do something that they have been slacking off by doing the fun thing. But then, so this was the beginning, around the beginning of the period. But then when I allow the model to change over time, this is what it looks like in the middle of the study. And it looks completely different for this person. And then in the end, towards the end of the observation period of 2 months or whatever it was, the situation is again very different. So think about if we were to use a model that assumes a stationary relationship between these variables. It would just give one number that would indicate the sort of average relationship between these two things over the whole time series. And that might not, if you remember, we were discussing the means and what the means mean in, for example, in the case of fat tails, or in the case of this the jagged net principle and such things. So the mean might be completely irrelevant. It might not actually depict anything of meaning, anything meaningful in this date.